Okay, this is lesson 14.2, sets of real numbers, and we're going to again explore the relationship between numbers. So, as you can see, I have this kind of box and box and box and box situation, and that's going to be a lot like what we did in the last part, thinking about where we lived in the world. But before we get to filling that out, I just want to define the categories in these boxes. So that's down here. So natural numbers are how we count. So if you're going to play a game of tag with somebody, or you're going to count out the number of goldfish crackers in a bowl, you are going to go 1, 2, 3, 4, and on and on and on till whatever. Whole numbers are a lot like the natural numbers, only they're just the positive numbers, and we're going to add 0 to it. So whole numbers are going to be 0, 1, 2, 3, 4, whatever. Because when you count, you don't start with 0. If you were playing tag with someone and you started with 0, they'd be like, what's wrong with you? That's not how we count. The integers are positive and negative numbers. So I can, come in -2, -1, 0, 1, 2, 3, and on back onto infinity. So I'm just looking at those positive and negative numbers. Those are my integers. Rational numbers, we are going to add my positive and negative numbers, but we're going to include fractions and decimals. So like -1/2, but 3/4 would also live in there. I could have 0.77. I could have -0.323. Ooh, and I could even have, I should put in here, I could have 2/3 in there as well. We'll talk about that guy in a minute. Irrational numbers are numbers that don't end or repeat. So our 2/3, like that, if I turned it into a or decimal, it'd be like 0.6666666666666666666, and I could go sixing the whole way forever because it just keeps repeating. Well, irrational numbers don't do that. They just go on and on forever, and there's not any kind of repeat to them. So maybe it's 0.1, 2, 3, 4, 5, 6. So while there's definitely a pattern and you can predict the next number, it's not like that repeating thing. So it would be an irrational number. And this is where we're going to find a lot of our square roots, the square root of 2. Because when we looked on our calculators, they just were numbers that went on and on forever for the most part. And so they are going to live in the irrational category. And real numbers, we're just going to say that they're not complex. And you're going to get into real numbers probably in algebra 2, maybe the end of algebra 1. We're looking at situations where we have a negative number inside of our radical. That's going to give us something that's not real, something that's imaginary. All right, so let's just focus on these guys here and this diagram. So the natural numbers, we already said that was how we count. 1, 2, 3, 4. All of those numbers live in the box. Our whole numbers, we just added 0 because the natural numbers are already inside that whole number box. This is kind of like the state of Pennsylvania, and this is Clearfield County. These were already a part of it. Excuse me. So out here on the edge, on the fringe, is just my 0. That's the only number I need to add to the whole numbers. In the integer section, now this box already contains my whole numbers, which is 0. Already contains my natural numbers, which is how we count. So the only thing I need to add to the outer rim of this integers box are some negative numbers. So let's do -6, -5, -4, -3. Just some examples of negative numbers. We're going to include them in here in our integers. And again, this is just kind of like, hey, I live in the United States. and I can drill it down to Pennsylvania, and I can drill it down to Clearfield County. All of these are like kind of lumped in together, or like the natural numbers are a part of all of these boxes. And we're going to move up into rational numbers. And we said that those were the fractions or decimals, negative or positive. So negative 1/2, 3/4, 0.77. And then our irrational numbers, well, my favorite irrational number is pi. It goes on forever and doesn't repeat, but the square root of 2 lives here. And while I said for the real numbers you couldn't have a negative inside, you could have a negative outside for rational numbers. So like the square root of 3, if it was negative, that would also be an irrational number. But I did mention that that square roots were tricky, and here's why. The square root of 25, if you do that math problem, it gives you 5. And 5 is a natural number. If I have negative square root of 36, when I take the square root, that's just 6. So my answer would just be -6, and that's an integer. Rational numbers, I can have that situation too. If I have a big fractional square root like this, if I have 16 over 25, when I take the square root of 16, that's 4. And when I take the square root of 25, that's 5. So when I do the math problem, it turns into a fraction number that belongs in the rational box. So just because you see square root doesn't mean that it's automatically irrational. You need to do the problem. And if the problem gives you like a decimal that goes on forever and doesn't repeat, then it's irrational. But if not, it could be in one of these other boxes.